October 12, 1943, Rayford Airfield, Alabama. The pre-dawn air hung thick with humidity as Technical Sergeant Marcus Washington stared at the grounded B-17 bombers, 24 flying fortresses that would never reach England if he couldn't solve their catastrophic engine failures. The young engineer believed he had discovered a solution that his white supervisors had dismissed as insane. Little did he know that his unorthodox repair method would not only save this squadron, but revolutionize aircraft maintenance across the entire Allied air fleet. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the remarkable tale of how one man's technical brilliance and stubborn determination helped turn the tide of the air war over Europe, when conventional wisdom had deemed it impossible. The problem had begun 6 weeks earlier. The 382nd Bombardment Group had been slated for deployment to the 8th Air Force in England, where bomber losses had become catastrophic. The Flying Fortress crews were desperately needed for the strategic bombing campaign against Nazi Germany, but during the final training exercises, engine failures had grounded the entire squadron. The Wright R-1820 Cyclone engines were failing at an alarming rate, far beyond normal mechanical issues. Lieutenant Colonel James Harrington paced the length of his office, occasionally glancing out the window at the useless bombers sitting on the tarmac. A former commercial pilot with Pan American Airways, Harrington had been given command of the 332nd Bombardment Group just 8 months prior. At 42, his salt-and-pepper hair and perpetually furrowed brow made him appear older than his years. The responsibility of sending young men into combat weighed heavily on him. "So you're telling me we're grounded indefinitely?" Harrington asked, turning to face Captain William Preston, the group's chief maintenance officer. Preston, a thin man with wire-rimmed glasses and prematurely receding hair, nodded grimly. "Yes, sir. We've replaced 16 engines in the past month alone. That's 4 times the normal replacement rate. Something's wrong with the entire batch we received, but Wright Aeronautical is claiming the engines meet all specifications." "We're supposed to be in England by November 1st, Harrington said. "That's less than 3 weeks away. What are our options?" Preston shrugged helplessly. "We've requested new engines, but with production already at maximum capacity, we've been told it could be 3 to 6 months before we receive replacements. Every B-17 coming off the assembly line has already been allocated." Harrington slammed his fist on the desk. 3 to 6 months? The war could be lost by then. There has to be something we can do." "Sir," Preston hesitated, "there is one other thing. It's probably nothing, but one of our mechanics has a theory about what's causing the failures." "Well, let's hear it then." Preston shifted uncomfortably. "It's Technical Sergeant Washington, sir. He's with the Colored Maintenance Unit." Harrington raised an eyebrow. "And?" "He's requested to examine one of the engines in detail. Says he has a hunch about the problem." Harrington considered this for a moment. The Army Air Forces, like the rest of the military, remained segregated. While the famous Tuskegee Airmen were making headlines as the first African-American pilots, most black service members were relegated to support roles. Having a colored mechanic propose solutions to white officers was unusual, to say the least. "Washington, that's the one with the engineering background, correct?" "Yes, sir. Studied 2 years at Howard University before enlisting. Smart as a whip, by all accounts." Harrington nodded decisively. "Let him look. At this point, we have nothing to lose." Technical Sergeant Marcus Washington had grown up in Detroit, the son of an auto factory worker who had moved north during the Great Migration. From an early age, Marcus had shown an uncanny talent for understanding how things worked. He could disassemble and reassemble nearly anything mechanical, a trait that had both impressed and frustrated his parents when he took apart the family radio at age 9. When the war began, Marcus had been in his 2nd year of engineering studies at Howard University. Like many young men of his generation, he had felt the call to serve. Unlike his white counterparts, however, his options had been limited by the color of his skin. The prestigious Tuskegee program was training black pilots, but competition for those spots was fierce. Instead, Marcus had enlisted and been assigned to aircraft maintenance, where his technical knowledge could be put to use. Now, as he stood in the maintenance hangar examining the disassembled R-1820 engine, he felt a growing certainty about his theory. The engine's cylinder heads showed unusual wear patterns, microscopic cracks that shouldn't have been present in new engines. Find anything interesting? Washington? Asked Staff Sergeant Ray Miller, his direct supervisor. Miller was one of the few white non-commissioned officers who treated the black mechanics with genuine respect. Yes, Sergeant, Marcus replied, pointing to the cylinder head. Look at these microfractures, they're present in all the failed engines. Miller leaned in closer. I'll be damned. What do you think caused them? I believe it's a metallurgical problem, Marcus explained. The aluminum alloy used in these cylinder heads has too much copper content. It makes the metal stronger initially, but more brittle under the thermal cycling conditions these engines experience. Miller whistled. That's quite a theory, but even if you're right, what can we do about it? We can't exactly manufacture new cylinder heads here. Marcus hesitated. Actually, I think we can fix them, but the process is unconventional. How unconventional? It involves heat-treating the cylinder heads in a specific sequence to re-anneal the metal. It would stabilize the crystalline structure and prevent further crack propagation. Miller raised an eyebrow. Where did you learn about this? My father worked in heat treatment at Ford before the war, Marcus explained. He used to bring home metallurgical problems to solve as puzzles. This reminds me of an issue they had with truck engine blocks in '39. And you think this will work on aircraft engines? The principles of metallurgy don't change, Sergeant. Metal is metal. Whether it's in a car or a plane. Miller scratched his chin thoughtfully. I'll take it up the chain, but don't get your hopes up. The brass doesn't usually go for unproven methods, especially not from colored mechanics? Marcus finished with a wry smile. Miller had the decency to look embarrassed. I was going to say junior NCOs, but yeah, that too. Still, I'll see what I can do. 2 days later, Marcus found himself standing at attention in Lieutenant Colonel Harrington's office, explaining his theory to the group commander and a collection of skeptical maintenance officers. Let me get this straight, Sergeant, Captain Preston said after Marcus finished his explanation. You want to deliberately overheat critical engine components, then rapidly cool them, and you believe this will somehow make them less likely to fail? Yes, sir, Marcus replied steadily. The process will realign the crystalline structure of the aluminum alloy and relieve the internal stresses that are causing the microfractures. That sounds completely backward, Major Howard Giles, the group's executive officer, objected. Heating metal makes it more brittle, not less. With respect, sir, that's not accurate for all metals or all heating conditions, Marcus explained. The controlled heating and cooling process I'm proposing, called annealing, actually increases ductility and reduces brittleness in this particular alloy. The officers exchanged dubious glances. And you learned this working on automobile engines? Preston asked skeptically. The principles are the same, sir. The specific temperatures and timing would be different, but the metallurgical science doesn't change. Harrington, who had been silently observing the exchange, finally spoke. What would you need to test your theory, Sergeant? Marcus thought for a moment. 1 engine to start with, sir, and access to the metalworking equipment in the base machine shop. And if you damage the engine beyond repair? Major Giles asked sharply. The engines are already failing, sir, Marcus pointed out. If my method doesn't work, we're no worse off than we already are. Harrington nodded slowly. You have a point there. He turned to Preston. Give Sergeant Washington one of the failed engines to experiment on. If his method shows promise, we'll consider applying it more broadly. But, sir, Preston protested, this is completely unorthodox. There are proper channels for engine modifications. And those channels would take months we don't have, Harrington interrupted. We're set to deploy in less than 3 weeks. If Washington's method fails, we'll request the deployment date be pushed back. But if there's even a small chance this could work, I want to try it. Captain Preston looked unhappy but nodded. Yes, sir. As Marcus left the office, he heard Major Giles mutter, This is insane. The next morning, Marcus began work in a cordoned-off section of the maintenance hangar. The failed R1820 engine sat on a sturdy workbench, already partially disassembled. Working methodically, Marcus removed the cylinder heads, 18 in total from the 9-cylinder radial engine. His plan was to heat-treat each cylinder head individually, following a precise temperature profile that would relieve the internal stresses without compromising the structural integrity of the metal. It was delicate work that required both technical knowledge and intuitive feel, something his father had called listening to the metal. Sergeant Miller stopped by midday to check on his progress. "How's it coming along?" he asked. Marcus wiped sweat from his brow. "Slowly, I'm still setting up the equipment." The machine shop supervisor wasn't exactly enthusiastic about lending me the tools I needed. Miller grimaced. "Yeah, old Jenkins is territorial about his equipment. Want me to have a word with him?" "No need to make waves on my account," Marcus replied. "I got what I needed eventually." Miller nodded, then lowered his voice. "Look, Washington, I want you to know that not everyone is rooting against you. Some of us understand what you're up against." Marcus looked up, surprised by the candor. "I appreciate that, Sergeant. Just be careful, all right? There are some officers who won't be happy if this works. Makes them look bad, you know? I'm just trying to fix the engines, Sergeant, that's all." "I know. Just watch your back." As Miller walked away, Marcus returned to his work with renewed determination. He knew the odds were stacked against him, not just the technical challenges, but the social and institutional barriers as well. But he had never been one to back down from a challenge. By evening, Marcus had constructed a makeshift heat treatment setup using elements from the machine shop's forge, modified to provide the precise temperature control he needed. Now came the crucial first test. He placed the first cylinder head in the heating chamber and began the process. The temperature needed to rise to exactly 930 degrees Fahrenheit, hot enough to reorganize the metal's crystalline structure, without reaching the melting point of the aluminum alloy. Marcus monitored the temperature gauge carefully, adjusting the heat as needed. After 30 minutes at the target temperature, he removed the glowing hot cylinder head using long tongs and immediately submerged it in a specially prepared oil bath, which would cool it at just the right rate. As steam hissed from the oil bath, Marcus couldn't help but wonder if he had just made things worse. Had he missed something in his calculations? Was there some crucial difference between automotive and aircraft applications that he had overlooked? He would need to test the treated cylinder head before proceeding with the others. That would require reassembling it into the engine and running it under load, a time-consuming process, but necessary to validate his approach. The next morning, with the help of 2 mechanics from his unit, Corporals James Wilson and Henry Tate, Marcus reassembled the engine with the single treated cylinder head, leaving the other 8 untreated for comparison. "You really think this is going to work?" Wilson asked as they carefully torqued down the mounting bolts. "It has to," Marcus replied simply. By mid-afternoon, the engine was ready for testing. They moved it to the test stand, a sturdy frame equipped with instruments to measure power output, temperature, and other critical parameters. A propeller was mounted to provide load on the engine. A small crowd had gathered to watch the test, including Captain Preston and, surprisingly, Lieutenant Colonel Harrington himself. The atmosphere was tense with anticipation. "Whenever you're ready, Sergeant," Harrington said. Marcus nodded and began the starting sequence. The engine coughed, sputtered, and then roared to life. The propeller blurred into a translucent disc as the engine warmed up. "Taking it to 50% power," Marcus called out over the engine noise. He advanced the throttle and the engine's roar deepened. The instruments showed all parameters within normal ranges. So far, so good. But the real test would come at full power, where the thermal stresses would be greatest. 75%, Marcus announced, pushing the throttle further forward. The engine responded smoothly, but this was still within the range where even the untreated cylinder heads performed adequately. The critical moment was approaching. "Going to full power," Marcus said, advancing the throttle to its maximum position. The engine's roar became deafening, and the entire test stand vibrated with the force being generated. Marcus watched the temperature gauges intently. In the failed engines, this was when the problems typically manifested, overheating in the cylinder heads, leading to catastrophic failure. 1 minute passed, then 5, then 15. The engine continued to run flawlessly, with the treated cylinder head actually running several degrees cooler than the untreated ones. After 30 minutes at full power, far longer than any of the untreated engines had lasted in recent tests, Marcus finally throttled back and shut down the engine. In the sudden quiet, Captain Preston's voice sounded almost too loud. Well, I'll be damned. Harrington stepped forward, his expression carefully neutral. Impressive, Sergeant, but one successful test doesn't prove the method. How quickly could you treat the remaining cylinder heads and run the engine again? With proper equipment and help, I could finish this engine by tomorrow evening, sir, Marcus replied. Harrington nodded. Do it, and document everything. Every temperature, every step of the process. If this works consistently, we'll need to replicate it for all the engines. As the crowd dispersed, Marcus caught Major Giles giving him a hard stare before turning away. Not everyone was pleased with the success, just as Sergeant Miller had warned. Over the next 24 hours, Marcus worked almost continuously, treating the remaining cylinder heads and reassembling the engine. Corporals Wilson and Tate stayed with him, catching short naps in shifts to keep the work moving forward. When the fully treated engine was finally ready for testing again, even more people gathered to watch. The stakes had been raised. If this test succeeded, Marcus's method would likely be applied to all 24 aircraft in the group. This time, Marcus ran the engine through a punishing test cycle, repeatedly taking it from idle to full power and back again, the kind of thermal cycling that had caused failures in the untreated engines. After 4 hours of flawless operation, Harrington had seen enough. Shut it down, Sergeant. I'm convinced. As the engine spun down, a spontaneous cheer erupted from the mechanics who had been watching. Marcus felt a surge of pride, tempered with exhaustion from the long hours. Harrington pulled him aside as the crowd began to disperse. You've potentially saved this deployment, Sergeant Washington. I'm putting you in charge of implementing this fix across the entire group. Captain Preston will assign you whatever personnel and resources you need. Marcus blinked in surprise. Thank you, sir, but won't that cause some issues with the chain of command? Harrington's expression hardened slightly. Are you refusing the assignment, Sergeant? No, sir, not at all. I just meant... I know what you meant, Harrington interrupted, his voice lowering. Let me worry about the chain of command. You worry about fixing those engines, is that clear? Crystal clear, sir. Good. Now get some rest. You look dead on your feet, and I need you sharp. As Harrington walked away, Captain Preston approached, looking somewhat chagrined. Well, Washington, it seems you'll be working directly with me for the duration of this project. The Colonel wants a full implementation plan on his desk by 0800 tomorrow. Marcus nodded, too tired to feel either triumph or apprehension. Yes, sir. I'll have it ready. Preston hesitated, then added in a quieter tone, That was impressive work. Unorthodox as hell, but impressive. It was as close to an apology as Marcus was likely to get, and he accepted it with a simple nod. The next morning, after 6 hours of much-needed sleep, Marcus presented his implementation plan to Harrington and his staff. The process would require setting up multiple heat treatment stations and training teams to handle the specialized work. With the right organization, Marcus estimated they could treat all the engines within 10 days, just in time for the scheduled deployment. 10 days seems optimistic, Major Giles objected. We're talking about thousands of cylinder heads. It's 18 cylinder heads per engine, sir, Marcus explained. With 4 treatment stations operating around the clock with 3 shifts, we can process 72 cylinder heads per day. That gives us the capacity to complete all 24 engines in exactly 10 days, with some buffer for unexpected issues. Harrington nodded approvingly. I like the thoroughness of your plan, Sergeant, but who's going to operate these treatment stations? This isn't standard maintenance work. I've identified 16 mechanics with the necessary skills, sir, Marcus replied. 8 from my unit and 8 from the main maintenance squadron. With proper training, they can perform the procedure reliably. Captain Preston raised an eyebrow. You're proposing mixed crews? Colored and white mechanics working together? The procedure requires teams of 2, sir, Marcus explained. Each team needs someone with strong mechanical skills and someone with a good eye for metal properties. The most efficient distribution of talent happens to cross usual unit boundaries. There was an uncomfortable silence as the officers processed the implications. Segregation was still strictly enforced throughout the military, with black service members kept in separate units under separate command structures. That's going to cause problems, Major Giles said flatly. Harrington drummed his fingers on the table thoughtfully. Perhaps, But we have a bigger problem to solve right now. If mixed crews get these planes ready for deployment on schedule, that's what we'll do." He looked around the table, challenging anyone to object. No one did. "Proceed with your plan, Sergeant," Harrington ordered. "Captain Preston will issue the necessary directives to form your teams. I want daily progress reports." "Yes, sir," Marcus replied, trying to keep the surprise from his voice. He had expected much more resistance to the idea of integrated work crews. As the meeting broke up, Sergeant Miller pulled Marcus aside in the hallway. "Did I just hear correctly? The brass approved mixed crews." Marcus nodded, still somewhat stunned himself. "Lieutenant Colonel Harrington approved it, yes." Miller gave a low whistle. "War makes for strange bedfellows, I guess. Listen, there's going to be pushback from some of the white mechanics. I'll help smooth things over as much as I can." "I appreciate that," Marcus said sincerely. "Don't thank me yet," Miller warned. "This is still going to be an uphill battle." Miller's prediction proved accurate. When the crews were announced later that day, there was immediate resistance from some of the white mechanics. Staff Sergeant Carl Dawson, a burly Texan with a perpetual scowl, was particularly vocal. "I ain't working with no colored boy telling me what to do," he declared loudly in the hangar. "That ain't right, and it ain't natural." Sergeant Miller confronted him immediately. "This isn't a debate, Dawson. These are direct orders from the group commander. You have a problem with it. Take it up with Lieutenant Colonel Harrington." Dawson glared but backed down. No one wanted to challenge Harrington directly. Similar scenes played out across the maintenance squadron as the integrated teams began to form. Some white mechanics accepted the arrangement with professional indifference, others with barely concealed resentment. A few, to Marcus's surprise, seemed genuinely curious about the innovative repair method and eager to learn. For their part, the black mechanics from Marcus's unit approached the situation with cautious optimism. They were used to doing essential work without recognition. The opportunity to demonstrate their skills alongside white counterparts was unprecedented. Training began that afternoon. Marcus had set up a demonstration station where he personally showed each team the critical steps of the heat treatment process. He emphasized the precision required. Too hot, and the aluminum would begin to melt. Too cold, and the crystalline restructuring wouldn't occur properly. "The metal will tell you when it's ready," he explained, demonstrating how the surface of the heated cylinder head would develop a particular sheen just as it reached the optimal temperature. "You have to watch for the signs and trust your eyes." Some of the mechanics caught on quickly, others required more coaching. Marcus was patient with all of them, knowing that the success of the entire operation depended on everyone performing their roles correctly. By the end of the first day, all 4 treatment stations were operational, and the first batch of cylinder heads was being processed. The work would continue around the clock, with teams rotating through 8-hour shifts. Major Giles made a point of inspecting the operation at the end of the day, his skepticism evident in every question he asked and every note he made. Marcus answered each query professionally, demonstrating the quality control measures he had implemented to ensure consistency across all teams. "And you're confident this treatment will last?" Giles asked. "We're not going to have engines failing over the English Channel, are we?" "No, sir," Marcus replied confidently. "Once the crystalline structure of the aluminum is stabilized through this process, it remains stable. These engines will actually be more reliable than factory new ones with the defective alloy." Giles made a non-committal noise and continued his inspection. When he finally left, Corporal Wilson let out a sigh of relief. "That man does not like you, Tech Sergeant," he observed. Marcus shrugged. "He doesn't have to like me. He just has to let me do my job." As the days passed, the operation settled into a rhythm. The initial tensions between white and black mechanics didn't disappear entirely, but they eased, as the shared technical challenge brought a sense of common purpose. Men who would never have spoken to each other under normal circumstances found themselves discussing the finer points of metallurgy and engine performance. Progress was steady, though not without setbacks. On the 4th day, one of the heating units malfunctioned, threatening to derail the schedule. Marcus and a team worked through the night to repair it, getting it back online just as the morning shift arrived. On the 6th day, they hit another snag when they discovered that one of the oil baths had been contaminated, potentially compromising a batch of treated cylinder heads. Marcus implemented an additional testing protocol to identify any affected parts before they were reinstalled in the engines. Through it all, Marcus maintained a calm, methodical approach that impressed even his critics. His technical knowledge was beyond question, and his leadership style, firm but fair, demanding excellence without belittling mistakes, earned respect across the maintenance operation. Lieutenant Colonel Harrington made daily visits to check on progress, often arriving unannounced at odd hours to see the operation firsthand. He rarely interfered, seeming content to observe and occasionally ask pointed questions about specific technical details. After one such visit, as Harrington was leaving, he paused beside Marcus. "You know, Sergeant, I've been thinking about what happens after we deploy." Marcus looked up from the engine diagram he had been studying. "Sir, this repair method of yours, it's not just applicable to our squadron. Every B-17 with these engines could benefit from the same treatment." Marcus hadn't considered the broader implications. He had been focused solely on getting the 332nd Bombardment Group into the air. "I suppose that's true, sir," he agreed cautiously. Harrington nodded thoughtfully. "I've sent a preliminary report up the chain of command, outlining your method and our results so far. There's been significant interest." Marcus wasn't sure how to respond. "That's good to hear, sir." "Indeed." "Keep up the good work, Sergeant." With that, Harrington departed, leaving Marcus to wonder what exactly was being set in motion beyond the immediate project. He didn't have long to ponder it. The work schedule was relentless, with new challenges arising daily. As they approached the halfway mark, fatigue began to take its toll on the crews. Marcus adjusted the rotation to ensure that no one was pushed beyond their limits, even if it meant slightly extending the timeline. "We can't afford mistakes at this stage," he explained, when Captain Preston questioned the schedule change. "Better to take an extra day and get it right than rush and compromise safety." Preston, to his credit, backed Marcus's decision, even when Major Giles objected to the delay. By the 8th day, they had completed treatment on engines for 15 of the 24 aircraft. Each treated engine underwent rigorous testing before being cleared for installation, and so far all had performed flawlessly. Word of the successful repair operation had spread beyond Rayford Airfield. Officers from other bomber groups began to visit, observing the process and asking detailed questions. Marcus found himself explaining his method repeatedly, each time refining his explanation to make it clearer and more accessible. On the morning of the 9th day, the routine was interrupted by the arrival of a staff car bearing insignia Marcus didn't recognize. From it emerged a silver-haired colonel accompanied by 2 civilians in business suits. Lieutenant Colonel Harrington met the visitors and brought them directly to the maintenance hangar. The entire operation paused as Harrington made introductions. "Sergeant Washington, this is Colonel Richard Atkinson from Wright Field, and these gentlemen are from Wright Aeronautical, Mr. Donovan and Mr. Schultz." Marcus stood at attention, suddenly very conscious of his oil-stained uniform. "Sir." Colonel Atkinson nodded briskly. "At ease, Sergeant. I understand you're the man behind this innovative repair method we've been hearing so much about." "Yes, sir, though I've had a lot of help implementing it." Of course." Atkinson turned to the civilians. "Gentlemen, this is your chance to see firsthand what Sergeant Washington has accomplished." The men from Wright Aeronautical did not look pleased to be there. Mr. Donovan, a heavy-set man with a florid complexion, stepped forward. "I want to be clear, Colonel, that Wright Aeronautical maintains that our engines meet all military specifications. If there are performance issues, they likely stem from improper maintenance or operating procedures." Marcus felt a flash of indignation, but kept his expression neutral. The implication that his unit was somehow responsible for the engine failures was as clear as it was unfair. Colonel Atkinson's smile turned frosty. "I'm sure you do maintain that, Mr. Donovan. Nevertheless, we have 24 aircraft that were grounded due to engine failures, and now they're being made airworthy through Sergeant Washington's method. I'm more interested in solutions than blame at this point." Harrington intervened smoothly. "Sergeant, why don't you show our visitors the treatment process? I believe Team 3 is just starting a new batch." "Yes, sir." Marcus led the group to the 3rd treatment station, where Corporal Wilson and a white mechanic named Parker were preparing to heat a cylinder head. The process begins with careful inspection, Marcus explained, falling into the instructional tone he had developed over the past week. We look for existing microfractures and document their location and extent before treatment. He guided the visitors through each step of the process, explaining the metallurgical principles involved and the precise control required to achieve optimal results. Despite their initial skepticism, the Wright Aeronautical representatives began to ask increasingly technical questions. "And you're saying the treated engines actually perform better than the originals?" Mr. Schultz asked, his initial hostility giving way to professional curiosity. "Yes, sir," Marcus confirmed. "The treated cylinder heads run an average of 7 degrees cooler under full load and show improved resistance to thermal fatigue in cyclic testing." "Fascinating," Schultz murmured, jotting notes. "And this could potentially be implemented at the manufacturing level?" "Theoretically, yes, but it would be more efficient to correct the alloy composition during initial production rather than treating finished components." Colonel Atkinson nodded approvingly. "Very impressive, Sergeant. Very impressive indeed." The inspection continued for several hours, with the visitors examining treated engines, reviewing test data, and questioning various members of the maintenance teams. Throughout it all, Marcus maintained his composure, answering each question with precision and confidence. When the visitors finally departed, Harrington pulled Marcus aside. "You did well, Sergeant." Colonel Atkinson was very impressed. "Thank you, sir. But I'm more concerned with finishing our repairs on schedule than impressing visiting brass." Harrington chuckled. "Fair enough. But I think you should know. There's talk of implementing your method across the entire Air Forces. Colonel Atkinson heads up Technical Services Command. If he recommends your procedure, it could affect thousands of aircraft." Marcus felt a strange mix of pride and apprehension. "Sir, I just wanted to fix our planes." "And you have," Harrington assured him. "Anything beyond that is, well, let's call it a beneficial side effect." The next day, as the repair operation entered its final phase, a new complication arose. Staff Sergeant Dawson, who had been operating Treatment Station 2, reported sick and was replaced by another white mechanic who had not been fully trained on the procedure. Marcus spent extra time with the replacement, walking him through the process step by step. But within hours, it became clear that the new man, Private First Class Reynolds, was struggling with the precision required. "I don't get why it has to be so exact," Reynolds complained after Marcus corrected him for the third time on temperature control. "It's just metal." "It's not just metal," Marcus replied patiently. "The entire process depends on precise temperature control. Too hot, and you'll weaken the structure. Too cold, and you won't get the crystalline reorganization we need." Reynolds muttered something under his breath that Marcus pretended not to hear. This wasn't the time or place for confrontation. "Let me show you again," Marcus said, taking control of the temperature gauge. "Watch the surface of the metal. See how it changes color as it heats. That's your visual indicator that you're approaching the target temperature." Reynolds grudgingly paid attention, and his performance improved somewhat. But Marcus made a note to check all of Station 2's output more carefully going forward. His caution proved warranted. Late that evening, as he was inspecting the day's production before leaving, Marcus noticed subtle irregularities in several cylinder heads processed at Station 2. The discoloration pattern suggested they had been heated unevenly, which could compromise the effectiveness of the treatment. Marcus immediately pulled the suspect parts from the production line and brought the issue to Captain Preston's attention. "We'll need to reprocess these," he explained, showing Preston the telltale signs of improper heating. "And I'd recommend additional supervision at Station 2 until Private Reynolds is fully up to speed." Preston frowned at the rejected parts. "This is going to put us behind schedule." "Yes, sir, but quality can't be compromised," Preston finished with a sigh. "I know. You made the right call, Washington." The setback added an extra day to their timeline, pushing them right up against the deployment deadline. The pressure mounted as they entered the final phase of the operation, with everyone working at maximum capacity to complete the remaining engines. On what should have been the final day, yet another problem emerged. One of the reassembled engines was showing unusual vibration during testing. The source wasn't immediately apparent, and Marcus spent hours methodically checking every component until he found the issue. A minute misalignment in the crankshaft that had nothing to do with the cylinder head treatment but would have caused catastrophic failure if not corrected. "This engine needs to be completely torn down and rebuilt," he informed Captain Preston grimly. "There's no shortcut." Preston looked like he wanted to argue but simply nodded. "How long?" "At least 18 hours, sir, and I'd want to run an extended test afterward to be sure." "That puts us past the deadline." "Yes, sir, I'm sorry, but there's no way around it." Preston took the news to Harrington, who appeared in the maintenance hangar 20 minutes later, looking grim. "Walk me through it, Sergeant," Harrington ordered, and Marcus explained the crankshaft issue in detail. After listening carefully, Harrington nodded. "All right, we'll delay the deployment by 1 day. Get it fixed right." "Sir," Major Giles protested, having arrived with Harrington, "HQ won't be happy about changing the schedule at this late stage." "They'll be a lot less happy if we lose an aircraft over the Atlantic," Harrington replied sharply. "The decision is made, Major. See to the necessary communications." Giles departed, clearly unhappy, while Harrington turned back to Marcus. "You have until 600 day after tomorrow, Sergeant. Not a minute longer." "Yes, sir, we'll be ready." The final push was exhausting. Marcus personally supervised the rebuild of the problematic engine, catching short naps on a cot set up in the corner of the hangar while critical procedures were running. The rest of the maintenance operation continued in parallel, completing the treatment and testing of the remaining engines. By 0400 on the morning of October 25th, the revised departure day, the last engine had been reinstalled in its aircraft and had passed all ground tests. The entire squadron was finally ready for deployment. As dawn broke, the airfield came alive with activity. Flight crews performed their pre-flight checks, ground crews made final adjustments, and the 382nd Bombardment Group prepared to depart for England and the war in Europe. Marcus stood off to one side, watching as the massive B-17s were rolled into position. He felt a complex mix of emotions: pride in what they had accomplished, concern about how the engines would perform under combat conditions, and a strange sense of loss as the project that had consumed his life for the past 2 weeks came to an end. Lieutenant Colonel Harrington spotted him and walked over. "You should be up front, Sergeant. Your work is what's making this possible." Marcus shook his head. "I'm fine here, sir. Besides, this is about getting those boys to England safely, not about me." Harrington studied him for a moment, then nodded. "As you wish. But I want you to know that your contribution has been formally recognized. I've recommended you for the Legion of Merit." Marcus blinked in surprise. The Legion of Merit was a significant decoration, rarely awarded to enlisted personnel and almost never to colored soldiers. "Sir, Don't say you don't deserve it," Harrington interrupted. "You do. Without your innovation, this group would still be grounded. Who knows how many lives your work will save, not just in this squadron, but across the entire air fleet once your method is fully implemented." Marcus didn't know how to respond. The recognition was unexpected and in many ways uncomfortable. He had done the work because it needed to be done, because he had the knowledge and skills to solve a problem, not for medals or accolades. "Thank you, sir," he said finally. Harrington nodded, seeming to understand Marcus's mixed feelings. "Colonel Atkinson will be returning next week to discuss implementing your procedure more broadly. I'd like you to be available for those discussions." "Of course, sir." "Good." Harrington extended his hand. "It's been a privilege working with you, Sergeant Washington." Marcus hesitated for a fraction of a second before accepting the handshake. An unusually egalitarian gesture from a white officer to a black non-commissioned officer. "Likewise, sir." As Harrington walked away, Sergeant Miller approached, grinning broadly. "Well, well." A handshake from the old man himself. "You're moving up in the world, Washington." Marcus smiled wryly. "Let's not get ahead of ourselves." "Are you kidding? You just saved an entire bomber group. That's the kind of thing that gets noticed." Before Marcus could respond, the first B-17 began to taxi toward the runway, its right cyclone engines roaring with healthy power. One by one, the massive bombers followed suit, forming a procession that would soon be airborne, heading across the Atlantic to join the strategic bombing campaign against Nazi Germany. As the last plane lifted off, disappearing into the morning sky, Marcus felt a deep sense of satisfaction. Whatever recognition might or might not come his way, he knew what he had accomplished. 24 bombers that would have been grounded were now on their way to the fight, carrying crews who would return home safely because of his work. "What now?" Corporal Wilson asked, coming to stand beside Marcus and Miller. "Now?" Marcus repeated thoughtfully. "Now we document everything we've learned so others can replicate it. This is just the beginning." In the weeks that followed, Marcus's prediction proved accurate. Colonel Atkinson returned with a team of engineers from Wright Field, and Marcus spent days walking them through every detail of his repair method. Technical bulletins were drafted, distributed, and implemented across maintenance units throughout the Army Air Forces. By December 1943, Marcus had been promoted to Master Sergeant and transferred to a technical development unit at Wright Field, an almost unprecedented move for a colored serviceman. There, he continued to refine and expand his heat treatment techniques, applying them to other engine components and even other aircraft types. The impact of his innovation extended far beyond the original 24 bombers of the 332nd Bombardment Group. As the treated engines proved their reliability in combat operations, the procedure was adopted more widely, eventually becoming standard practice for all Wright R-1820 engines in service. Statistical analyses later estimated that Marcus's method prevented hundreds of engine failures during critical combat missions, saving countless aircraft and lives. The fuel efficiency improvements from the treated engines also allowed bombers to extend their range, reaching targets deeper inside enemy territory. After the war, Marcus Washington returned to Howard University on the GI Bill, completing his engineering degree and going on to a distinguished career in metallurgical research. The techniques he pioneered during those intense 2 weeks at Rayford Airfield found applications in commercial aviation, automotive manufacturing, and eventually the space program. Yet for all the accolades and recognition that came later in his career, Marcus would often say that nothing compared to the moment he watched those 24 B-17s take to the sky, flying on engines that conventional wisdom had deemed beyond repair, saved by a method that skeptics had called insane. It was a testament not just to his technical brilliance, but to his perseverance in the face of both technical challenges and social barriers. In solving a critical wartime problem, Marcus Washington had demonstrated that innovation could transcend prejudice, that expertise should be recognized regardless of its source, and that sometimes the most valuable solutions come from the most unexpected places. The 332nd Bombardment Group went on to fly numerous successful missions over Nazi Germany, with their engine reliability rate becoming one of the highest in the 8th Air Force. The squadron's achievements were due in no small part to the fact that their flying fortresses were powered by engines that had been saved from the scrap heap by one engineer's insane idea, an idea that ultimately helped turn the tide of the air war over Europe and brought countless young airmen home safely to their families. As for the Wright Aeronautical Corporation, they eventually acknowledged the metallurgical issues in their cylinder head alloy and incorporated Marcus's heat treatment process into their manufacturing procedures, though they never formally credited him with the innovation. It wasn't until 1992, nearly 50 years later, that the company's successor officially recognized Marcus Washington's contribution in a ceremony at the National Air and Space Museum, presenting his family with a plaque commemorating his achievement. By then, Marcus had been recognized with numerous honors, including induction into the National Inventors Hall of Fame and the award of an honorary doctorate from Howard University. But those who knew him best understood that his greatest satisfaction came not from personal recognition, but from knowing that his work had made a difference, that his knowledge, skill, and determination had saved lives during a critical moment in history. In later interviews, Marcus would often be asked about the insane repair method that had made his reputation. His response was always the same. There was nothing insane about it. It was just good engineering applied where it was needed. The metal doesn't care what color the hands are that work it. It only responds to knowledge and skill. This principle, that expertise and innovation should be valued regardless of their source, became Marcus Washington's lasting legacy. As important as the technical breakthrough itself, In demonstrating that an African-American engineer from a segregated unit could solve a problem that had stumped the industry's leading experts, he had challenged assumptions and opened doors that would ultimately lead to greater opportunities for those who followed in his footsteps. The story of how one African-American engineer's insane repair saved a doomed bomber squadron became more than just a footnote in the history of World War II. It became a powerful example of how individual brilliance, when given the chance to shine, can overcome institutional barriers and change the course of events in ways that extend far beyond the immediate challenge being addressed. For the airmen whose lives were saved by engines that didn't fail at critical moments, for the engineers who learned from his innovative approach to metallurgical problems, and for the young people of color who found inspiration in his example, Marcus Washington's contribution represented something profound. A reminder that true expertise transcends artificial boundaries, and that sometimes the most valuable solutions come from voices that might otherwise have been silenced. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.